Alright, now let's continue on with 2.2. So first things first, we have a area formula for a trapezoid, and we have a trapezoid drawn here. And the thing is, we need to find side B, but we also need to figure out, well, wait a minute, which one of those is sides H and A? Good question. The sides H and A, sorry, I'm just trying to deal with the shadow here. Close enough. The sides H and A will go as follows. The A and B, if you remember from geometry, should be the parallel sides, and the height is the one that should be making 90-degree angles with both of them for a trapezoid. So in that case, once I say that, hopefully you realize that, well, the capital A is going to be the area, the 11,250 that we were told, and we then have a 1/2, and the height, the thing that's not parallel, is the 75. And then we have the 140 for A, and we want to find B. So that's going to be our initial setup there. From there, what we're going to need to do is we're going to need to, get B isolated. Now, to me, I think the easiest way to deal with that is to kind of do what we did in the end of 2.1 and realize that I don't actually need to multiply 1/2 times 75 and get some decimal, and I don't need to distribute 75 to both of these and get some really big numbers. What I can go ahead and do is I can still just kind of deal with each of these multiplications, because after all, it's a multiplication and a multiplication and a multiplication. All three of those will multiply in some order, and I can go ahead and just start undoing those multiplications by first maybe multiplying the reciprocal. Alright, when I multiply the reciprocal, that means the 1/2 is going to go away on the left, and that's going to leave me with, let's see here, 22,500. That's going to still be 75 times the 140 plus B. At that point, I can divide out the 75, because it was going to multiply to both parts, so it can divide from both parts. And that will leave me with, 22,500 divided by 75 is 300. And that's still going to be equal to my 140 plus B. I can, of course, subtract the 140, and I'd end up with 160. And by all means, go ahead, plug that back in, and make sure it works. Up next, for this next question, we've got a rectangle, although that kind of looks square, but that's kind of one of those, figure isn't drawn to scale kind of ideas. And they tell me about the perimeter, and they give me this formula that has a P and then length and width. Now, you might be a little confused where this formula comes from. We'll explain that in a second, but first let's use it as it said and kind of show you where L is coming from. First, it says the perimeter is 228. Now I need to figure out what L is. I just see some W's here, but it says the length is 8 more than the width. So in other words, this W plus 8 is actually the length, and so I can substitute that in. Right? They said length is 8 more than the width, so L is the W plus 8 that they're showing me here. Now 2W is essentially 2 times the other thing here, which is just W. At that point, I'm good to go. If that's a little confusing, here's another way of thinking about perimeter, maybe a little easier. Well, since this is a rectangle, if W is over here, it'll be W over here as well. If W plus 8's on top, we'll have W plus 8 on the bottom as well. And if you think about walking around, we can say it verbally this way. At some point, you'll walk the W and the W, so 2 of the W's. You'll also walk around a W plus 8 side and another W plus 8 side, so 2 of the W plus 8 sides. So that's where this formula is really coming from. All right, let's go ahead and work it out. From there, we distribute the 2. We've got 228 equals, I'm going to think a little ahead here. That'll make 2W. There already was a 2W, so now I've got 4W. Again, just working a little bit ahead. And then 2 times 8 is 16. All right, from there I can subtract 16, which would be 212 from both sides. From there I can divide 4, which would be 53 is my width. All right, as always, I recommend plugging that back in just to check your work. If I do that, I have two 53s, which makes 106. And if I have a 53 plus 8, which is 61, and I have two of those, let's see, yep, 228 for my perimeter. So we found it. All right. Next page. Up next, we got a little bit more geometry to still work through. So we have this kind of crude picture of a house and a lot, and they want to know how much lot or how much area is left over after you build the house on the lot. In other words, how much is left on the lot after you put a house on it? How much lawn are you going to have is another way you could say it. Well, we again have two rectangles, it looks like. And so we're dealing with area now. The way you find area for a rectangle is base times height. Notice they didn't give you that this time. They would expect you to remember that formula, but they'll help you out with the trapezoids. From there, let's see here. Well, we have an entire lot, so we'll say that. So the lot is going to be the 41 times 60, just that rectangle. And the house is going to be the 8 times 32. All right, if we work that out, I really need to have a calculator close by. I keep losing it. You'll get 2,460 for the lot and 256 for the house. At that point, the leftover, if you want to call it that, would simply be the total area minus the house. All right, so 2460 minus the 256. I'm getting 2,204. And that would be our total leftover area. All right. This next formula is probably, honestly, the one that's most important to us in our real life, daily life, because a lot of us, deal with interest, whether it be cards, credit cards, or cars, credit cards, homes. Everything's got an interest rate. So really learning simple interest and compound interest, which is what most of those things I named actually use. They use compound interest, not simple. Which means you either are making more money or losing more money, depending on if you're, investing with that interest rate or borrowing on that interest rate. Anywho, this is a pretty important concept to understand. So let's dive in and look at this formula. Here's the formula. B equals P plus PRT. So let's now read through and figure out what I can plug in. So we have a 5.7 interest rate, or interest. I kind of jumped ahead with the words there. And 3 years. So far R and T aren't quite clear. Maybe you know ahead of time. But what it does say is balance is 4,684. So I'm pretty sure that means the capital B would be this amount. Now up next it says I want to calculate the principal. That's the idea. So I'm looking for P. I don't know what it is. But there's an interest rate of R. So there's my percentage. So I can substitute that in. What you need to know is we never, ever, ever use true percentages in our math formulas. We use their decimal equivalent, which is what you get when you move the decimal place over twice. If you already have a percentage, move it over twice and write down whatever that is. You don't have to write a leading zero. I usually don't, just because I think it's easier to see sometimes, but if you do, that's fine. And then it says after T years, and here we have 3 years, so we'll just have another multiplied by 3 here. All right, let's clean this up a little bit. We have our 4,684, and now what I'm going to clean up is I'm going to keep the P on the left, and on the right-hand side, I'm going to turn this into, kind of normal stuff that we're used to seeing. So if I take 0.057 and I multiply it by 3, I get 0.171 or 0.171. Again, you can write the leading zero, but you don't have to. And then the P. Because, right, when we have some term that has a variable, we usually write it at the end after we write the number. Now, the next step here is so silly. It's so simple, but a lot of people mess up when they see it, which is a little silly. They don't know what to do with the p here and the 0.171p. But the idea is, remember, this is a 1p and this is a 0.171p. You just add those two values. What's 1 plus 0.171? Well, it's 1.171p. At that last point, all you need to do is divide the 1.171, and you will have isolated p. And so now I know, or I'm about to find out, that, oops, let me type it in, 1.171 on the bottom times 4,684 is 4,000. All right. Now, again, I just got to say it out loud because of the times we live in. I know it doesn't seem like a lot to, put 4,000 away and only, quote unquote, get $684 back. But technically, at that point, that's free money. And 5.7% does beat inflation. And, there are actually a lot of online banks you can go to and get around 4 or 5% interest, which, again, is higher than inflation. So, people say all the time, oh, money's just being lost to inflation if it sits. Not if it sits in an account earning over whatever inflation is in interest. So this is actually a pretty good deal. And remember, this was simple interest. Compound interest is actually what happens with those accounts you hold. And so you would actually get more than 684, maybe not too much more, but still, free money over time is better than no money or money chewed away by inflation. So as long as your interest rate's higher in that high yield savings account, then you're in a good situation. All right, real life lesson over, back to the math. We alluded to this before, but if I see the words less than or more than, that means we're going to switch the order. So less than, fewer than, more than, greater than. We don't need to worry about that for the more than and greater than, but for the subtraction, it definitely matters. So we have this phrase, 1 less than 2 times a number is 11. I mean, first thing, let's look at these 4 answer choices. If it ends with is 11, hopefully we know we're definitely choosing C or D, right? They're not saying do some ahead work. They're saying write this equation as we set it. So is 11 equals 11, it's definitely C or D. I mean, from there, the other thing that's nice is they didn't actually quiz us on the less than switching the order, so it has to be D because that's the only one that was phrased correctly and had subtraction in it. So, not too bad there, but let's make it a little worse or more complex. Up next, we've got 4 less than 13 times a number. All right, so 4 less than 13 times a number. Take a look at all 4 of these choices. Which one does 4 less than 13 times a number, which again means the order should be switched here. Well, so far, the only 2 that seem like they could be possible are A or C, because they're the ones that at least have the 4 on the end, but it's 4 less than this product. In other words, the 13 times a number, just like 2 times a number, go together. So in this case, the answer is going to be C. All right. And then it says is equal to that number added to 8. And again, the order switches there, but that's addition. It technically doesn't matter. So those 2 aren't too bad because they're process of elimination. But we've got a big one here that we'll talk through that we don't have process of elimination. We actually have to figure this out. So here we go. We have 31 less than the product of, I'm just going to stop right there and say something. So I've got 31 less than some product. What we should be familiar with at this point is that means there's a minus 31. There's something in front and then minus 31 because, again, less than means switch the order. Now, what's in front is a product. Now, think about this. A product is 2 things multiplying. So when I see the word product, I'm looking for two things, which would be 7, and I'm going to write the difference. So what's multiplying is 7 and some sort of difference. You know what it sounds like? It sounds like I need parentheses because it's 7 times 7 is multiplying 2 because it's a product, some sort of difference. And what is that difference? A number and 2. All right. That is a mouthful, but kind of think about those wordings again. So 31 less than, at that point, you know it's minus 31, and then whatever they say second is actually what goes first. Again, if there's a product of something, that means two things are multiplying. So 7 and some sort of difference are multiplying. So 7, and I need parentheses here because I don't know what this difference is, but a difference is two other pieces. Now what are those two other pieces? A number and 2. From there it says is, so that's equals, twice the number, 2n. Now I used n here, you could have also used x, but this one again is pretty tricky, but if you can get through this one and get your mind around this one, I don't think we're going to see anything more complex in the course. What we didn't do in these are usually they're going to ask you to choose the right problem and then solve it, but based on 2.1, I bet that's not going to be too difficult. It's the wording that's the hard part. And that's 2.2, so great, we've now gone through 2 sections. Let's go ahead and dive into the third. For the third, we're going to talk about inequalities, and we're going to talk about simple linear inequalities. And so the first thing is, what is an inequality? Well, it's these. The less than or equal to, or the less than or greater than, and the less than or equal to or greater than or equal to. All right? These inequalities mean that we're, if we want to say it this way, really simply, our solution will not be a single value, but a range of values. So there's multiple solutions for inequalities, usually. I guess I should put usually, because you never know. There's always edge cases in math. But we're just going to say usually, or mostly would be a better word for this section, and for us in intermediate algebra. But the idea is we're going to have, again, a range of values. Now, you can kind of see below here and look ahead. There's definitely multiple ways to write a range of values, and that's kind of what this section is about, is introducing those. The math is going to be easy to solve, but the question is, how do I take what I just solved and turn it into a range of values? How do we express that mathematically? That's what we're here to figure out next. And part of that is going to be shading. And that will pertain to the graph. I think that's what we'll remember most. And so for shading, what we're going to say is the less than or greater than, use parentheses, and the less than or equal to or greater than or equal to, use, all right, square brackets. Now, that's going to go for graphs or for interval notation. So the good news is you're going to learn a little bit of a different graph, because we used to do, I'm going to write it in parentheses to say we used to do it. We used to do open circle and closed circle, maybe in elementary school or middle school, if you remember this concept. But the book decided to kind of help you and say, well, a lot of people have trouble with interval notation. So why don't we swap out the open circles and closed circles for the same notation we use in interval notation, and maybe that'll make our stuff easier. So let's look at this and let's see what's going on here. Let's say we had two solutions. Let's say, and you can kind of look below at what's going to happen. We're going to solve some algebra, and let's assume we solved some algebra, and one of my solutions was that x is greater than or equal to 2, and let's say my other solution was that x is less than -3. Now, the first solution type is called set builder. This one's a little bit too easy and a little bit too boring or redundant. But set builder notation, your homework will provide you or pre-fill you with something that looks like this. And I'm going to just kind of put this in dashed underlines to say that the dashed underlines is going to instead be like a little box that you type your answer into. So set builder notation is these weird curly brackets. That's what denotes a set in mathematics. And we don't have time to cover all of what a set is, but essentially, you guessed it, a set is a range of values. It's a way of saying there's more than one thing in here and what things are inside here. And so, well, what you do with set builder notation is you actually just rewrite your variable solved on the left and you move on. The way you read this mathematically is it's the set of all x values where this statement is true. All right, so again, the set is the curly braces where x, or how do I want to say it? The set of all values of x, and this line could be thought of as the line where, and then this statement is true. So set builder, you're just rewriting your answer that you solved, like when you did your algebra, you got x by itself on the left. Just rewrite that inside these curly braces provided for you online in the homework. Great, that's not too bad. I know interval notation's next, but I think I want to go ahead to the graph because I think that one's a little easier. The graph for both of these would be a simple horizontal line because it's only one variable right now. And so, we might have 0, 1, 2. They might skip things and count 0, 2, 4. Just be careful about the online graph that they provide for you. Again, you'll be drawing none of this by hand in your homeworks or exams. They're provided for you. You just have to select the right one. So 0, 1, 2, 3. Over here we've got -1, -2, -3. Now, with both of these graphs, we then need to graph, and we used to, again, do closed or open circles, but now we're using either parentheses or square brackets. So what does that look like? Well, for the first one, if x can be greater than, remember in elementary school, the alligator's math opens towards the bigger thing, so x is the greater one. So what does it mean for x to be greater than or equal to 2? Well, it means I could be 2, or I could be 3, or 4, or 5, or 6.2387, 7.2935, it could be anything as long as it's greater than 2. How do I draw that? Well, again, because it's hard parentheses, I draw 2. And notice I'm drawing my, not hard parentheses, but square brackets. I'm going to draw that square bracket pointing to the north of 2, or sorry, I guess to the right of 2, because that would be greater than. And then I even go ahead and draw an arrow and point it and say, yep, it could be equal to 2 and anything further to the right. Right? Greater has an R, right has an R, so when you say greater, think right. When you think less than, think left. Now, the great thing is your online homework doesn't quiz you on did you have this square bracket in the right direction, so that's nice that they don't make you guess on that. But you'll need to kind of learn that, okay, it starts at 2, and then if the arrow's going to point that way, the parentheses are going to kind of, or square brackets are going to wrap around the arrow that you're drawing out. Okay, based on that, hopefully you can look at the second example and think about what that's going to look like. And yep, you're going to have a parentheses now, not a square bracket, because we only have the less than, we don't have the or equal to. And we're going to go more to the left because less than has an L, left has an L, and there we go. Now when we look at these two, we start to see, or if you've looked at interval notation and you look at the graph, eventually they start to click and you start to understand what's going on. But interval notation, if we could define it this way, is a succinct way of describing the graph you would draw. So it's a succinct way of describing this graph that I drew. And what I mean by that is it's going to tell you the lowest value you can have and the highest value you can have with the correct symbolism. So interval notation, if I look at this graph, the lowest it goes is 2, and I can be 2. So I use bracket 2. Again, that's the lowest or the furthest left this graph goes. It goes up to 2, and then it goes no further, but it can be 2. So use the same sign, square bracket, square bracket. Then you write a comma, and what does the comma denote? It denotes everything in between the greatest value. And so then you say, okay, well then what is the greatest value? And the problem is this goes on forever, and we need a symbol that denotes going on forever, and that symbol would be infinity. It's pretty much a sideways 8. Now this is where we need to make one thing clear, is that the square brackets are, again, for when you can be something exactly. And so even though I used a square bracket on the left and it's tempting to put a square bracket here to match it, we're actually going to use a parentheses, because again, parentheses in this symbolism denotes something that you can't actually touch, and infinity is a concept. You can't touch it. So infinities will always have a parentheses, but your numbers, if they're the or equal to, if they're that barrier point on the or equal to, then they're going to have the square bracket. So the other one, again, it's a simple and succinct way of writing your least to greatest value. It goes in least to greatest order always. So this graph, when I look at this graph, what's its least value? Well, its least value is negative infinity. It goes left forever, negative infinity. And then comma for everything in between. And then what's its highest value? Well, its highest value is negative 3. And then what symbol do I put on it? A parentheses, because I cannot be negative 3. I can only get close to it. All right. And there we go. We've just learned interval notation. So hopefully over time you learn that, okay, interval notation is just saying, yeah, where's that barrier point? Or notice this, interval notation is going to use that same number in your solution. It's just, is it on the left or is it on the right, based on can your graph go right or left? And then again, infinities will always have parentheses. So hopefully you start to learn that, okay, yeah, 2 to infinity, 2 to infinity. Negative infinity to negative 3, negative infinity to negative 3. It's your least to greatest value just collapsed into two little symbols with either square brackets or parentheses. All right, now I've got this one rule written here. You might be wondering what that is. The one rule is when dividing by a negative, the inequality flips. All right, hopefully we remember that. Usually everyone remembers that. That's kind of why I'm jokingly calling it the one rule, because it's the one rule everyone somehow remembers. Once you say when dividing by a negative, everyone knows the answer. So great. Hopefully we remember that. All right, now so far we've just gone over the theory of what we're going to do. Now let's actually do it, right? So we had some solutions. The question is, how do we get these? Well, we look at examples like these. Now this should look just like 2.1 work. It shouldn't look too crazy. We're just going to get x by itself. We're going to subtract 6x. 11 minus 6 is 5. There's a negative 7. This is a little funky. We haven't seen this yet. There's now nothing on the other side. Well, that's just 0. From there, all I have to do is add 7 to the other side, which I'm just going to do like that and kind of not write the whole thing out. Then I just need to divide by 5, and unfortunately, oh man, I already have a fraction again. But this would be my kind of answer. And so, again, what we discussed was there's 3 different solutions. The first solution is the set builder. So in other words, take your homework, find the box that essentially just rewrites this whole thing. There you go, that's set builder. So really nothing to it. But next, we need a graph, we need interval notation. I think let's do the graph next. This one's a little bit interesting because we've got 7/5. Again, your online homework will provide the graphs, you just have to choose the right one. 7/5, you need to think about where that is. 7/5 is 1.4, so it should be about somewhere right here between 1 and 2, but a little bit closer to 1. Now, 7/5 can be less than, or sorry, x can be less than or equal to 7/5, again, because the alligator's mouth is going away from the x. So x can be less than 7/5, and so, or equal to, so that means hard bracket, but already pointing to, or the curved or square brackets are pointing towards the left, and then we draw an arrow to finish it off. There's my graph. And then my interval notation, my third solution, again, the graph should make it easy. It's going left forever, that's negative infinity. And it goes up to, well, that same number I already had in my solution with the harsh bracket. Again, right, it's the same exact thing, it's just you're condensing, drawing the arrow to just a comma between those two values. Awesome. Let's look at the next one. The next one, we've got some distributive property. Again, please, oh gosh, this is not 3 minus 2 is 1 and then do the other stuff, because, right, 2 and this parentheses are multiplying. PEMDAS says multiply before you subtract. So this distribution is multiplication. Multiplication M happens before S subtraction in PEMDAS. So make sure you distribute it first. So negative 2 times n is, well, negative 2n. Negative 2 times negative 4 is positive 8. And that's going to be greater than negative 1. We've got some like terms there. We got to take our 3 and our 8 and realize that those will be 11. We can then subtract the 11 from both sides. That will be negative 12. And we can then divide the negative 2. I know I'm going a little quick, but this should honestly be a review. But oh wait, we just divided by a negative. So we flip the inequality, and now we get 6. Again, by all means, pause the video, take your time, spend a little more time on it. But hopefully 2.1 went well and you went through all the homework and took your time on it so that the rest of the stuff ends up being easy by comparison. All right, so we have this here. I'm not going to bother with the set builder notation, but let's just graph this thing. Well, we're going to have 0 in the middle. Just for scale, I'm going to, I guess, put 6 over here just to have some other number and not to waste space. And this says n is less than 6. So less than 6 means to the left, so I already know I have an arrow going this way. And then again, I need a symbol to kind of hug around where the arrow is going. And in this case, since it's not or equal to, I'll use parentheses. Awesome. There's my graph. At that point, interval notation is just the same thing, just rapidly condensed. So it goes left forever, negative infinity. It goes up to 6, but does not touch it because it cannot be equal to, so parentheses. And we're done. All right. Hopefully those two went well. Let's do a little more, if I can find my page. There we go. All right. Again, we should be able to start going really quick now, so subtract 6x from both sides. That's negative 2x. I'm going to simultaneously subtract 3 from both sides. That's negative 8. Notice the inequality hasn't flipped yet because I haven't divided by a negative yet, and it's dividing strictly by a negative. If you just divide by a positive, don't worry about it. But here we go. Here is that step. I will divide by negative 2 now to get x by itself. And so now that's going to be x is less than 4. And honestly, at that point, again, we're just going to graph. Here's 0. Here's 4. I guess we could write negative 4 as well. So there's my number line. I can be less than 4, so there's me being less than 4, but I can't be equal to 4, so parentheses. Once again, that simplifies just to negative infinity, 4 parentheses. Right? Really, hopefully at some point this starts going by about this fast, right? The algebra hasn't been too complex. Until we get to here. We get to revisit our fraction help again. So remember that we learned that you can multiply by the LCD and eliminate fractions entirely. So the LCD in this case, what all my denominators can divide nicely into is, think about it for a minute, and of course always, as the great Khan of Khan Academy would always say, pause the video, try it yourself. If you haven't done that yet, really, hopefully you're spending some time trying these out before just watching me go over it, and you're using that as a help. Probably should have said that before, but also we should hopefully know that as we go into our work, that we shouldn't just watch it all, we should try some of it first. Anywho, 20 will be your value that all three of your denominators can divide cleanly into. So here we go. 20 over 4 reduces to 5, but then multiplies to 3 to leave you with, 15n. That's a 15. Let's make it look like a 15. All right, up next, 20 times -1. Well, that's just -20. Inequality stays the same because I haven't divided by a negative yet. 20 times a half is just 10. And then 20 times 1/5 is, again, if you notice it, it reduces to 4. All right, that's the heavy lifting. And the great news is, hey, look at that. There's no more fractions. So we can now go lightning quick, subtract the 10n from both sides. Add the 20 as well, because you might as well, do as much as you can on the same line as you get comfortable balancing more than one thing to do at a time. 5n is greater than or equal to 24. And of course we can divide by 5 and just get 24 over 5. This time there was no flipping of the inequality because, again, I did not divide by a negative. Okay. 24 over 5, just remember that that's, here's 0, here's, let's see here, 5 and 4, right, to some sort of scale. Remember that 24/5 is almost 5, but it's not quite there yet. So be careful when you look at those graphs. They'll probably have the scale be a little, wider to see it clearly. But for this graph, again, I can be greater than almost 5, so greater than almost 5, but I can also be equal to that value that's almost bigger than 5. So we use that square bracket. And of course that means the interval notation would be that square bracket, that value that we put the square bracket on, and then positive infinity because this is going right forever. Remember, your infinities have parentheses even if you use the square bracket because, again, the parentheses are for can you touch that thing exactly? And for infinity, the answer is no because it's a concept, not a number. But for 24/5, you bet you can because it had the or equal to. Awesome, we're doing good. But now we've got word problems. So, let's see if I can check the zoom here a little. It's kind of fuzzing. It says plumber A charges $75 for a service charge and $40 an hour. Plumber B charges $50 an hour but no service charge. How many hours must a job last for A to be less than B? So the issue here is, at some point, if we kind of look at it, A charges less per hour, but we have an upfront fee. But depending on how long they're going to be out on the property, at some point, 40 an hour beats 50 an hour. That's kind of the magic going on there. When does that happen? Well, let's create some equations. We want plumber A to cost less than B. So that's what we're looking for. And plumber B is pretty easy. Plumber B just charges $50 per hour. Per means multiply, or 50 an hour. Now on the other side, we've got a little bit more going on here because they say we are charged a 75 service fee and then 40 an hour. So that means there's 75 just no matter what, no variable. 75 is what they charge just for coming out to the property essentially to look at it. And then 40 an hour. All right. Now I don't need the multiplication dots here. I can just write 50h and 40h, but I was just building up to it as we go. All right. Even though we want A to cost less, you might think we need A to solve on the left. Really, it doesn't matter how you solve it. Either way, we're solving this equation for A to be less than B. So now let's solve this and see what happens. I think, for me, it's easiest to just subtract the 40h to the other side. That's kind of why I was saying this is still solving the question of when will A be less than B, but I'm just solving for H on the right-hand side because it was easier to just move that one value. At that point, all I need to do is divide by 10, and I'm actually done. I'm going to reorder it as I write it. Now watch that, because as I divided by 10, I knew this was going to be 7.5. Now watch this, as I divided by 10, my inequality didn't flip, but I said I wanted H to be on the left. Now because my inequality didn't flip, if I divide 10 and H is alone, notice the alligator's mouth was opening to the H. And so if the alligator's mouth isn't flipping, but I want to reorder my inequality, then the alligator's mouth still has to be facing towards the biggest thing like it was before. So after dividing by 10, H is still the biggest thing. It's opening to H. So if I reorder it, H is still what it opens to. It's, again, not that I divided by a negative. It's just I wanted my variable on the left-hand side for convention. But there's your answer. If the plumber is going to be out there for more than 7.5 hours, you should go with plumber A, because that point at 7.5 hours is where them charging you less per hour essentially makes up for the $75 you paid up front. All right, let's look at the next one. It says we've got 15 players on a team, and they want to go to a tournament. That tournament, to travel there, will be $650 plus $75 per player. Hey, we kind of heard that wording before a little bit ago. And then it says the team this time just has a $1,500 budget, and how many of the players can go. All right, so let's see here. In this case, it's that my expenses essentially have to be less than or equal to, right? A budget, you can hit your amount, you just can't go over it. So my expenses cannot exceed 1,500. Or another way of writing that is the algebra, the 650 plus the 75 per player, has to be less than or equal to my budget. All right? So really, hopefully when you look at that and think about all that setup, that wasn't too bad. But really, spend time on these examples trying to think about what is that formula that I'm going to be using, because honestly, that's the hardest part, is writing the formula. The solving usually is pretty quick after that. Speaking of which, all you'll do is you'll subtract the 650, which will leave you with 850, and then you'll divide the 75, and that will actually give you, let's see here, I get P is less than or equal to 11.3. Now, for practicality purposes, that means 11 or fewer can go, because you can't actually bring 11.3 people. You have to bring 11 or 12 or 13 or 10 or 8 or whatever. But for our budget, we can bring 11 or fewer. All right. It then says graph the solution. Well, again, don't get intimidated by that. You just have 0 here. You have 11 here. And you put a hard bracket at 11. And you go to the left. Now, it depends on if they want the, I guess we could say it this way, the practical solution, which is, again, well, that's only 11 people. Or do they want the theoretical solution? Do they actually want the 11.3? Just check the small blue font on the bottom and they'll, give you some hint as to which one of those they want. All right, last one here. I think this is the last one. Yeah, is pretty relevant to us, right? We have 4 exams in this class. Let's say you've taken the 3 and you want to calculate what you need for your final grade. Well, let's see how to do that. The student wants an 89.5, and we already know the student's first 3 grades. And hey, look, there's that vocab. What range of scores are possible to still get an A in the course? All right, well, we have an average of 89.5, so we want our grade to be at least 89.5. At least means you could be 89.5 or more, because again, we'll round up the 0.5 and above, and I'll do that for you as well. But now the question is, well, the average has to be greater than or equal to that number. How do we find an average? Well, an average is every value, 87 plus the 91 plus the 83, and here's the trick. plus the score I don't know yet, all over the amount of exams I will take, which is 4, because at some point I will take the 4th exam, and so I will be dividing by 4. I just don't know what that 4th score is yet. Okay, that's the heavy lifting here. It's not too bad. We'll take 89.5, multiply it by 4, and that gives me 358. So I now have 87 plus 91 plus 83 is greater than or equal to 358. Whoops, and the plus x. Sorry, I forgot that. Oh, I have to draw it nicely. Plus x greater than or equal to. There we go. At that point, I need to add those other 3 scores together because they won't combine with x, they're just next to it. So 87, 91, 83, 87, 91, 83. I'm getting 261 there. And so my last step is just to subtract the 261. So 261, subtracted from 358 is a 97. Alright, so that's a pretty high bar for a final exam, but if that student gets a 97 or above, they'll still have an 89.5 for their final grade. That gets us through 2.3, so we'll stop this video and start another one for the next few sections.